So here in this video, we can consider the following grammar, and um, we have given an input string that is int id comma id, int id comma id. So we need to pass this particular input by using a shift reduce parser. Okay, and the given grammar is this grammar. Okay, so now we can see the stack implementation of this particular parser. Okay, so here we need to have two data structures, that is a stack. Okay, and we need to have input buffer also should be there. Okay, so the initially the stack will be having only a dollar symbol, and the input symbol after the end of the input symbol also we have a dollar symbol. So the initial state will be like this way, that is stack with the dollar symbol, and the input string is int id comma id, and it will have a dollar symbol at the rightmost end of this buffer. Okay, now we have two different functions, that is a shift and a reduce function. Shift function means that is we are shifting our symbols, the input symbols from the input buffer to the stack. Okay, so if you are pushing this int towards the stack, then that action is called the shift. Okay, okay. So next action is a reduce action. That is, we can pop out the symbols. Here in this shift reduce parser, we can pop more than one, zero or more elements can be popped from the stack, and these are popped based upon the productions that is given in the grammar. So we need to see the right hand side of the productions. So that means symbols will be popped from the stack, and this symbols will be replaced by the left hand side of the same productions. Okay, so we can see it out how we can do it. Okay, so here this int is we are doing an action shift action, that is int is shifted to the stack. So now our stack will be dollar int. Okay, and this is again we have when once it is int is shift to this stack, will the input buffer will be having id comma id, again the dollar symbol. Okay, so next we have a next operation, that is a reduce operation. That is from the given grammar, we have a production, that is t gives int is there. So here stack top is int. So here this the right hand side of this production can be replaced by the left hand side of this particular production. So here inside the stack, this int will be popped out. Okay, and we can push capital T non-terminal to the stack. Okay, so here T will be int will be popped and T will be pushed to the stack. So input buffer will be appearing the same as it is. Okay, now again we can do a shift of operation, that is id is moved to stack. So here we'll next we will have T and id. Okay, so again we can have a production, that is L gives id. Okay, so by applying this rule id instead of id, we can have a L. Okay, so L is id is replaced by id. So here T L will be there. Okay, so next we can have a shift operation, that is a comma operator is moved to the stack. So here stack will be TL comma. Okay, so here this is the operation. Again there is a shift operation, that is id will be moved to stack, that is TL comma id. So here TL comma id. Okay, now we have a protection, that is L gives L comma id is there. So here more than one symbol is popped from the stack, that is L comma id. This L comma id is popped from the stack. Okay, and we can push the left hand side of the production, that is here it is L, capital L. So this will be popped out, and this L will be pushed into the stack. So we have a dollar symbol will be there, then T will be there, and these will be pushed, and the left hand side of the production is L. So L will be this will be popped, and we can push L inside the stack. So here your stack will be dollar symbol TL. Okay, so now onwards your input buffer is empty. Still your stack is not empty, right? So we need to do the operations. That is, again there is TL is there. Okay, so there is a production that is S gives TL. So here we can reduce the reduce operation can be applied. That is, instead of TL, this will be popped out from the stack, and the right hand side of this production is S, right? So we can push the symbol S here. Okay, so here we'll be having a dollar symbol and a S. Since this is the condition, that is we can stop our operation, that is the input buffer is empty, as well as a stack is having a start symbol. So here in this grammar, S is the start symbol. So now we can accept this accept this input string for the given grammar. Okay, so here we have shown how this input string is passed by using a shift reduce parser. So mainly there are two functions. One is shift and second one is a reduce function. Shift function, just we are moving the first symbol of the input buffer to the stack top. Okay. Then reduce means based upon the productions which is given in the grammar, we have to pop all the symbols from the right. We have to consider the right side of the production and pop that much symbols from the stack, and replace that symbols by the left hand side of the productions, and that particular terminal should be pushed into the stack. That is what we are doing in a reduce operation. Okay, so finally we have the next action, that is accept action. That is, we have accepted that particular given string for this given grammar by using a shift reduce parser. Okay, I hope it is clear. Thank you.